So if you are in, and if Hello everybody, my name is Mike Geig, and welcome to another one of our live presentations here on Twitch TV. Um, Hopefully everybody can hear me, and if no one can, just let me know. And well, I guess you wouldn't hear me to know to say that, but I'm sure someone will eventually be like, "Hey, nothing is being heard," so, and let me know. So before we start, oh, fantastic. Before we start, we are using a different chat this time, so we're not using the Twitch built-in chat. Instead, we're using Chatroll, and so we're trying this new service out. So if you are in Twitch chat, you should be able to see the link to the Chatroll. Otherwise, you can come right over here and see it is chatroll.com/Twitch-live. All right, so okay, so. Oops, I went full screen there. Sorry about that. And so you should be able to come to this site and participate into the chat and kind of go from there. All right. So, and real quick here, I noticed that it's making noise for me. There we go. Muted. Perfect. Okay. So, I apologize. My taskbar is going to pop up every once in a while. I have it minimized right now, but you're going to see it. So feel free to take a look at the applications I have on my taskbar and enjoy. Okay, so last time we met, if you weren't here, hopefully maybe you watched the video, or maybe if it was something that was more of a review for you, then you maybe didn't need to watch it or whatever. But last time we talked about the Unity editor. We talked about all of the different windows, the different views. We talked about assets and things like that. So today we are going to go ahead and build off of that and kind of talk a little bit more about the fundamental elements of game development and the fundamental elements of game development with Unity. All right. So, you know, feel free again, just like last time, hop in with any questions you might have. We have Will Goldstone here monitoring the chat. He will do his best to answer any questions you have, or to forward it to me so that I can ask or answer the questions here on the live presentation. So feel free to just hop in and kind of get involved and talk with each other, and let's make this a community thing. So, all right, before we get into a lot of the Unity specific stuff, I wanted to talk about some of the fundamental idea, concept behind video game development, and how these modern engines work and render things to the screen and stuff like that. Because knowledge of this stuff will be very fundamental, very helpful in working in games in the future. So this might be a review for some of you. This might be brand new to some of you. Either way, just, you know, let's go through this stuff here, and then we can move on to some more advanced topics. So the very first thing I want to talk about is I want to talk about the coordinate system. Everything in video games is based off a coordinate system, and that coordinate system is very mathematical in nature. It's based off a Cartesian coordinate system, and it is how we develop games and build them to be rendered on the screen. All right, so our classic games like our Marios and our Pac-Man and whatever, our 2D games, use a 2D coordinate system. And I have a little graphic here to help us. So we have this 2D coordinate system. And the 2D coordinate system is just that. It's two dimensions, it's X and it's Y, it's flat. Okay, 2D coordinate system. And we can see that here on the left. Now, our 3D games, a little bit different, at a third dimension, obviously, and that axis is the z-axis, or towards you and away from you, the viewer, all right? So 3D has the three dimensions, x, y, and z. This is important to cover. I mean, this might seem fairly basic, but this is important to cover because not all game engines and not all 3D software use the same coordinate system, all right? So, for instance, with Unity, Y is up and down, X is left and right, and Z is in and out. However, if you use something like, say, UDK, Z is up and down and Y is in and out. So if you're used to working in one, you have to kind of adjust to the system of another. So that's why it's important to know. So Unity, we use a Y is up and down, Z is in and out. That's also important to know if you do 3D modeling of any sorts, like say Blender or Maya. They treat Z as up and down and Y as in and out, so that when you import assets from one of those 3D modeling softwares, you'll have to change the rotation before you can use them in your game. So the 3D coordinate system is kind of important to understand from that regard. So all games are based on one of those two systems. Now, Unity is a 3D engine, obviously, so we can do volumetric things with cubes and spheres and all three dimensions. However, that doesn't prevent us from making 2D items in a Unity game per se. We just change kind of how we're going to do it. So for this time so far, we've been using something called an orthographic camera and just disregarding the z-axis to build 2D games in Unity. And I'll show you what that looks like here. So what I'm going to do is I'm going to kind of put something in the scene here. I'm not going to really talk about how I did it because we're going to cover that here in a little bit. So what I want to do is I just want to kind of throw a cube in here. You all should be able to see the menus now. We've changed kind of the way we're looking at this. But you can see we have a cube here, and I'll go ahead and put it at 0, 0, 0. And if we click on our camera, we can see, hey, we have this cube. And that's all well and good. And we can actually rotate our cube, let's say like 45 degrees. About the y-axis like this, and we can look at it again and we can see kind of it's rotated. And I'll actually bring my camera in a little bit so we can kind of get an idea of the perspective there. Alright, so if we look in the game view, we can kind of see this perspective based rotated cube. Okay, this is a standard 3D system. If we wanted to make a 2D game in Unity, alright, we could always, with our camera selected, change our projection right here to orthographic. In doing so, changes how we see, and you can see here if I go back to perspective, like that, to orthographic, like that. And I'd actually have to reduce the size pretty significantly here. And you can see now, we don't have that perspective anymore. What we're looking at is completely flat. I bring this up just as a, hey, this is good to know, in case you were making 2D games in Unity. Even though Unity is a 3D engine, you can still do this. Now, all of this that I'm mentioning is the way we made games, and we still kind of do, but interestingly enough, Unity will be having the 2D toolkit coming out, basically the 2D capabilities of the engine, to do all this in a much more streamlined fashion. That's really not all that important for today. I just kind of wanted to throw that out there so you were aware of it, and to know that 2D and 3D is still relevant, and we still use them very much in video games today, and Unity is still very capable of doing both of those. Okay, so that's like my kind of little spiel there about 2D versus 3D. I think we all understand 2 dimensions versus 3 dimensions, and I don't feel like we need to cover it in much greater depth than that. Alright, now one other thing related to the concepts of game development that is very important is this idea of the coordinate system. So I talked about 2D and 3D, and both of them use a coordinate system. Alright, so you noticed when I moved my cube, right, and I moved it to 0, 0, 0, which you can see up here in the upper right hand corner, alright, I basically put it at the center of this world's coordinate system. Alright, and I can change this. Let me remove this rotation here. I can change this to be like, say, 5, and you see that it moves to the right. It moved 5 units along the positive x-axis in this coordinate system. The reason that's important is because we have 2 types of coordinate systems. We have a global coordinate system, and we have a local coordinate system. Alright, all objects are based off of this global coordinate system. So if I were to take this cube and I were to create a sphere, which I will do by clicking Game Object, Create Other, and then Sphere, and if I were to put them both at 0, 0, 0, they would both go to the same spot. Alright, the cube just happens to be on top of the sphere. Because this is the world coordinate system. Every object in the world shares this coordinate system. We also have something called the local coordinate system. And the local coordinate system is the coordinate system as it relates to a specific object. All right, so this cube is positioned on the world coordinate system, but anything I do to the cube specifically happens to its local coordinate system. And I have a little graphic for that too, which looks like this. And basically, this shows us our two coordinate systems. So what we have is we have a square that's in the exact same spot, but there's two ways of looking at its four vertices. Okay, so in the upper left-hand corner, or the left-hand side of the image, we have a world coordinate system, where we have a square and all of its vertices are relative to the world's origin, and the origin is 0, 0, 0. It's the intersection of all three axes. And the right image shows us our local coordinate system. And the local coordinate system is the position of each of our vertices as it relates to the center of that particular square. All right. Now, this isn't going to be important just yet, but later on when we start talking about transformation, that's going to become very important. The idea or the knowledge of local versus world coordinate system. So just remember, there's always two ways to talk about position. You can talk about position relative to every other item in the world on the world coordinate system, or you can talk about position relative to one particular object, which is a local coordinate system. So just kind of store that information away. We will be using that here in a little bit when we start talking about some of the ideas or concepts behind these game objects. Okay. Hope you like my little graphics there. Hopefully they showed up all right and they enhanced the video. I know my graphical capabilities might stagger some. All right. So let's talk about this idea of a game object. And I'm going to go ahead and get rid of these. So a game object, at its very basic root, is the most fundamental element of a scene. All right? A game object is basically what makes up everything that we can see and interact with and work with in a Unity game. If you'll recall, a scene is maybe a particular level or a particular grouping of assets. We talked about that in the last video. So every scene is made up of a lot of these different game objects. And the game object could be the player, the game object could be a car, enemies, bullets, buildings, walls, blocks, clouds, the sun, whatever. All right? Whatever we happen to build, as it were, we can build out of these game objects. At their core, game objects are basically just empty containers. All right? They're buckets that we can stack a bunch of different things into and add all sorts of functionality. So let's take a look at our most basic game object type. I can create game objects a bunch of different ways. So I could come over here to the hierarchy view and I could click create and I could choose I'm sorry, never mind, it's not in here. This is only very specific built-in stuff, so disregard what I just said. Instead, come up here to game object and create empty. I apologize. That's what we want, create empty, which you could also type or hold Control Shift and hit N, or if you're on a Mac, Command Shift N. I believe it's Command Shift N. I don't have a Mac, so please tell me if I'm wrong, but I believe Control is replaced by Command on a Mac. But we're going to go ahead and create this empty here, right there. And we are going to see what we get. And what we get is nothing, right? It's kind of a not a thing. We can click over here in our hierarchy view and see that a game object has been added to the hierarchy view, but that's it. If we look over here in the inspector, we can see that there's not much to it. The only thing we could see is that we have this name, the fact that it's enabled, which we can remember disable it by clicking here, tags and layers, and this transform component. And I will talk more about what these components are here in a little bit. But basically they add our functionality. So these components, this empty game object isn't very pleasing in the eyes. It doesn't really do anything, doesn't really have anything. It simply exists as kind of this placeholder that we can put all sorts of functionality on. Now, we'll look at actually adding functionality to this here in a minute. So let's just go ahead and get rid of this for now. All right. So, you know, basically we have this stackable functionality, but let's look at some of these game objects that already kind of do stuff. So again, this game object menu here at the top, if I click this and go down to create other, we can see all of these different type of game objects that we can create. This is what we see too when we go to the hierarchy view and we click the create right here. So I could click create and I could click cube. Okay, and so this is still just a game object, like we saw the empty game object, but look at all the other things that are part of this. All right, this has a mesh filter, a box collider, all right, a mesh renderer, which is how we see our block, and we have a material section for our mesh renderer to draw, right? So these are all the components of this particular cube game object, and we can add components, we can remove components. If I really wanted to get weird with it, like I could click on my mesh renderer here and I could remove that component, and we can see now that we just have this box collider, all right, with nothing else to it. I can hit Control Z to undo that. I could remove my mesh filter, all right. I can remove the box collider, all right. I can re-add those. We can add and change functionality. And we have quite a few of these to choose from. So some other ones we can look at is sphere. A sphere is also another very useful one to look at. We have our capsule, cylinder. One that we're going to use a lot is a plane. A plane is very useful because it's a 3D shape that's really 2D. And that's cool because we can see it's flat. It's useful for putting stuff on it and whatnot. But the underside of it is not rendered. All right, so we can see it here, and if we go through it and then look up, we can no longer see it. Okay, so a plane kind of acts as a 2D shape. Only one side of it is rendered, and that gets very useful if we want to put like a texture on it or something like that, but we don't want it to cast a shadow, or we don't want to be able to see it from the other side, or whatever. They're very efficient and they're very simple to use. All right, they make great backstops, if you will. And I'm actually going to use it as a backstop right now. So we have this plane, and what I want to do is I want to rotate it. All right, let me find my camera. Let me help me align myself in the scene there. Oh, there's our camera, and let me get that back into perspective view. And let me put this back. Click on my plane and put that at 0, 0, 0. There we go. And I'm going to move my camera back to where it started. Okay. So all I did is clicked on my camera and went to -10. Which moved it back away, and then I put my plane at 0, 0, 0, and I'm going to go ahead and take my sphere and also put that at 0, 0, 0. There we go. And so we can see how this plane makes a very useful backstop for other objects we might create. So with my sphere here, I'm going to go ahead and move it kind of towards my camera a little bit by putting it at, like, say, -3. And I'm going to take my plane and I'm going to rotate it. Now, if you're not really following along, that's fine. We haven't really talked about these transformations yet. I'm basically doing this for demonstration purposes, but I'm going to show you in more detail what I'm doing. So kind of just watch and follow along, and you'll see kind of more about what I'm doing here soon. But I am going to rotate, oops, not 90 degrees, 270 degrees. There we go. So that the plane pops up, because we want to make sure the visible side is toward our camera. So our camera can see the plane. Now, let's talk about some other game objects that exist. Well, how about lights? I can click create and then create myself a point light right here, and boom, I have a point light. All right, and now if I look at my camera, I can see, or let's go up to game view, I can see the point light emanates light all around. All right, and we could create a bunch of different things like that. Like if I didn't want a point light, I could click create and directional light. All right, and change the direction of the light and stuff like that. So basically, these game objects, there's a lot of different game objects, and the only reason they're different is that they have different components on them, and that kind of changes how things work. All right, so let's talk about this idea of components. Okay, I'd mentioned components several times, and now let's kind of talk about what they are. So components are the things that we add to game objects that give them their ability. All right, so a game object by itself is just basically a container. The component is the thing we put in the container to make it useful. So kind of prove my point here, we have this directional light, we have this sphere, and we have this plane. Well, I'm going to click on this directional light. I'm going to get rid of it. All right, which makes things very dark. What I want to do is I want to click on my sphere, which is right here, and I want to add a light to it. I mean, there's no reason that another game object can't be a light. There's nothing different between a light and any other game object. They're both just game objects. The light game object just happens to have a light component, which, as it's a component, can be added to anything. All right. So the way we add a component is we can do one of two things. All right. We can click the component menu at the top and scroll through the different components, or we can come over here in the inspector and click Add Component. Both will bring up the exact same menu. All right. So I'm going to click Add Component, and I'm going to go to Rendering, and I see my light right here. Boom. Now my sphere is a light. It's also a sphere. Okay? The only reason the sphere is appearing dark is because the light is emanating from it and not on it. Okay? Light does not illuminate the object that it's on. If we wanted the sphere to glow from the light, we'd have to put something like an emissive texture on it, an emissive material on it, or something to make it look like it was glowing. I mean, it is emitting light, but it's not itself glowing because the light is coming from it, not on it. All right. So we can put all sorts of components on this thing. Right now we can see that it has a sphere collider. And sphere colliders is something we'll probably talk about later when we're talking about interaction and things like that. But let's say I didn't want this thing to behave like a sphere. I could remove this sphere collider so it no longer behaves like a sphere. And we could see the green lines that denote the collider. You see these lines right here. When I remove that, go away. And instead, I want it to behave like a capsule. So I can click Physics and Capsule Collider. Now it looks the same until I go to the Capsule Collider component and I change its height. Oh, that was too much. There we go. There we go. And we can make it behave like a capsule now, physically speaking. Or maybe we don't like that. Maybe let's go to Physics. Let's try a box. There we go. So now even though it's a sphere, it'll land and sit flat like a box will. Okay. Again, we can make it look like a box, behave like a box, add a bunch of different lights to it. Let's say I wanted this to be both a point light, like we have here, but I also want it to be, let's say, a directional light. So I can come back here to rendering. I can add another light to it. Oops, never mind. I apologize. We can achieve this effect by nesting, but we can't have two lights on the same object. So that's my mistake. And I can actually show you guys how to do that here in a little bit. But the idea is that we can add components to change how it works. So I'll show you here that we can just take the point and we can change that to directional and change its color and do all sorts of wacky stuff with it. All right. Control Z undoes the things we just did. So these components help us achieve all sorts of things. Some of the other kind of the fun examples of a component, we can come to component and we can do, let's see, is it rendering? I'm looking for the specific one I want. It's not rendering. Miscellaneous. Effects. There we go. Particle system. Look at that. And we can make it emit particles. Okay? And so we can do things like that. And I'm not going to get into talking a lot about our particle system because there's a lot to know about the particle system, and we'll definitely cover that at another time. But again, our particle system is just a single component that can be attached to anything. All right, we can put that particle system on any game object, right? That's the most important thing that I'm trying to get across, is that the particle or any component is just that, a component. It can go on any game object to give any functionality that we want to basically anything that we want. So very powerful stuff. We can remove components just by right-clicking on the component in the inspector and click Remove. You can also minimize components just by clicking on their name, left-click. Right-clicking removes it. Okay. So that is kind of my spiel about components there. The specific components will be covered in their own sections as we talk about them, but just know that they're all fairly universal. They kind of swap in and out, and they can make any game object behave like any other game object, because all game objects are just basically generic containers. Okay. That being said, I'm going to go ahead and delete my sphere and delete my plane. To do that, I just click on it and click the delete key. You You could also probably click on it, right click and select delete. One thing you might have noticed is that everything I add to my scene now is dark. Let me come here and add a cube. Before, the cube looked white, didn't it? Now it's dark. The reason for this is that we added a light to our scene at one point. If you were following along, then you added a light to your scene. Still white. And the reason for that is when we add a light to our scene, Unity automatically turns off the universal lighting, okay, which we can actually see right up here. Okay, it's this button right here where it says toggles the built-in lighting on and off. So since we no longer have a light in our scene, I want to turn that off. And now we're back. Okay, we will use Unity's built-in lighting to help us see. Okay, so if you happen to have a dark cube, just turn the built-in lighting back on by clicking it, and you'll be good to go. Alright, I'm also going to click this button here so we get our grid back. That grid's going to prove to be useful here in a moment. And I'm going to take my cube, and I'm going to be sure to position it at 0, 0, 0. Okay, so now what I want to talk about is this concept of transforms. Transforms and transformations, which all very closely ties to this coordinate system. Alright, I talked before about the coordinate system, about how every coordinate system has an origin, which is at 0, 0, 0, or 0, 0 in a 2D coordinate system, and that's where our axes basically meet each other, intersect with each other, alright? And all points kind of go from there. Everything is kind of based off of this origin. So every game object has a transform, which you can see up here in the inspector. A transform. And what a transform is it's an object's unique position, rotation, and scale in the world. Every object has a transform, and it is comprised of those three very specific things. From our transform, we have what's called transformations. Okay, and that's a very important distinction. So if someone talks about the transform, they're talking about something's position, rotation, and scale all together in one thing. That's its transform. However, if they're talking about a transformation, they're talking about one very specific thing. They're talking about maybe the change in its position, or the change in its rotation, or the change in its scale. All of those three things are called transformations. So we basically perform transformations on a transform. All right, and that might seem a little confusing, and hopefully we can kind of break that down and explain that a little bit more. There are three types of transformations. Okay, there's what's called translation, and translation basically means moving left, right, up, down, in, out. If you change an object's position, you have translated it. Okay, translation. Then we have rotation, which should be pretty obvious. The rotation is where we turn an object. We say we rotate about an axis, okay? And then we have scale. And scale is both the noun and the verb. It has a scale and we scale it, all right? So scaling is where we make it bigger, smaller, things like that. And we can do these through code, through the visual editor, and through the inspector. So let's talk about translation first. Translation is us changing the position. We can select our translation tool right up here. Okay, it's this basically this cross with the 4 arrows, or we can hit the W key. So I can select it with the mouse, or I can hit W, and we see that what we have is this little transform gizmo. Okay, like we talked about last time, red is always your x-axis, blue is always your z-axis, and green is always your y-axis. And what you can see is when I click on one of these arrows and move my mouse, we are actually moving this object's 3D position. We are translating it. Okay, and you can watch the inspector to see me translate along the z-axis, and me translate along the y-axis, and along the x-axis. Okay, I also have the ability to manually put in where I want this to go, or if I click beside the value, see how we have the value 2 here, and if I move my mouse over, I get this little mouse with 2 arrows on it. If I click and hold, I can do this. Okay, so we have a bunch of different ways of changing the values. We can also change them in code, but we're not really going to get into the code today, the actual scripting. We're going to see how much we can do here inside the editor. So again, translating is a transformation that changes the position of a transform. Okay, 4 specific terms that are all related to each other, but they kind of mean different things. All right, so just so you know, that kind of smooth that out there for you. All right, so the very next thing is the rotation, and the rotation allows us to move about an axis. Okay, that's the term. We move about an axis, which allows us to rotate around that axis. And we can select the rotation tool by clicking here, okay, or by hitting the E key, which will bring up our rotation gizmo. And we can see our rotation gizmo here. And I like that gizmo to be a little bit bigger, so I'm going to click here. And oh, that doesn't let me change the gizmo size. Okay, never mind. I figured that would allow me to change my gizmo size. I guess I can just I can move out, which will make the gizmo relatively bigger. So with rotation, it's not exactly how you would think. All right. So notice how with translation, the red arrow for X is going left to right. All right. However, when I click rotation, you'll notice that it's going up and down. That is because while the x-axis is left and right, to rotate about the x-axis moves us like this. All right, a little bit different than you might be expecting. The basic way to conceptualize this or to think about this is if I wanted to move an object about the x-axis, I would imagine a pin basically piercing the object along that axis so that the only way it could turn would be about that pin that was stuck to it, right? That held it in place. Likewise, if I had a pin coming from top to bottom piercing this object and kind of pinning it in place, I would only be able to move like this. This is the movement about the y-axis. All right, and then finally, this is the movement about the z-axis. All right, or axis, I guess, if it's plural, or singular, it's plural. But yeah, so basically our rotation in the different axes works a little bit different than our translation. So in this case, rotation is a transformation that rotates an object's transform. Okay, so that's kind of how those terms kind of fit together there. The last one to talk about, and let's reset this here, 0, 0, 0, and we can change these values the same way as well, just like we could, or manually type it in, either way. All right, the last one I want to talk about is scale. And scale we can get by clicking here, or by hitting the R button, and that gives us our scale. And just as we would expect, scale just allows us to click and drag, and scale an object. Okay, so we can make it bigger, we can make it smaller, and actually when we get in a negative it flips, just like that. We kind of want to avoid negative scale usually. Unlike the other transformations, we don't go to 0, 0, 0 with scale. Okay, we go to 1, 1, 1. All right, scale is a coefficient where we take an object's normal size and we multiply it by its current scale. So a scale of 1, 1, 1 means the object is 100% of its normal size. A scale of 2, 2, 2 means it's double its size. So we don't go down to 0 because that would be 0 times its size or nothing. All right. So unlike position and rotation, all right, scale has 1, 1, 1 for its values. It always has some size. If we want it to be half as big, we make it scale 0.5, 0.5, 0.5, and so on and so forth. All right. So that's kind of how we manage our scale. And again, scaling, I guess, is the transformation that we apply to the scale of a transform. So to kind of recap all that, the transform is the thing that is made up of the position, the rotation, and the scale, and transformations are what we apply to a transform to change it. And our 3 transformations are translation, rotation, and scaling. Okay, so now that we have that, one very important topic is to talk about the order of operations with transformations. Okay, so what order we do these in has a really large effect on the outcome. Remember when I talked about the local versus world coordinate system? Okay, and I had mentioned that all the transformations are applied to the local coordinate system and not the world coordinate system, and that is still very much true. While the transform is based on the world coordinate system, the transformations are based on the local coordinate system, and I can illustrate this for you. So I'm going to come down here so I'm a little bit closer to this cube. All right, and let's pay attention to this grid up on the bottom here, these lines. Okay, so let's say I want to move an object, basically, let's say 1 unit to the right along the positive x-axis, and I want to rotate it 45 degrees along the z-axis. Okay, so just remember that. 1 unit to the right, positive x-axis, rotate about the z-axis. So I'm going to get my translation tool just by hitting W here, and I'm going to move this. I'm going to translate it until it's about 1. You know, that's not great. Let's do 2, just so it's more exaggerated. Okay, so that's about 2. I could type 2 in here to get closer, but that's fine. I want to do this by hand. Then I want to rotate about the z-axis. So I'm going to hit E to get my rotation tool, and I want to do about 45 degrees. And so, okay, there we go. So, and that's our final result. Okay, so what we did is we translated and then we rotated. Okay, let's bring it back. I'm going to hit Control Z here. Now, let's start by rotating. All right, so I'm going to rotate it 45 degrees. There's about there. That's close enough. All right, and now I'm going to translate it. Uh-oh. Do we see the difference? All right. Now, when we rotate and then translate, the object appears in a completely different position. Okay? Because locally to this object, X is now this way. That X-axis has been modified, and we can actually see it with the gizmo. We can see how X is different and Y is different. If I go along the Y, I'm no longer going up and down. I'm kind of going up and to the left or down and to the right. Right? So that is all completely changed. Furthermore, let me reset this back to the way we want to be. If I scale it, so let's say I'm going to scale it to 2, 2, 2, and now I want to translate it. All right. I can't quite tell if it was scaled or not, but generally speaking, the translation is scaled. So if the object is double its size, it needs to move twice as far to move 2 units. Okay, so the size of an object affects its translation, the rotation affects its translation, right? The rotation affects its scaling, so always be sure to kind of do things in the right order to get the end result, because the local coordinate system is going to change, all right, as we perform transformations on it. And it's that local coordinate system that kind of determines how things are going to look and how things are going to behave and how things are going to work with each other. Okay, so far I've talked about our game objects, I've talked about the 2D, 3D, the local versus world coordinate system, components, and some transformations. The last thing I want to talk about today is this concept of parenting or nesting or grouping, which is very important in Unity and helps us very much keep items together and make items behave in a very specific way. So I have this sphere. All right, and I'm going to go ahead and position it at 2, 0, 0, just like that. I'm sorry, I called it a sphere. It's a cube. I was looking down here and I saw a sphere. So we have a cube, I'm sorry, and I'm going to position it at 2, 0, 0. I'm now going to add a sphere, and I'm going to push this at negative 2, 0, 0. All right, so we have these two objects, one a sphere and one a cube. I have the capability in Unity to group these together or parent them together. All right, and the way I do this is I simply come to the hierarchy and I click one and I hold it and I drag it onto another one. And now we see this little arrow appear next to cube. All right, and we can see that sphere is underneath of it. So if I click cube, it selects both. And if I click sphere, it just selects the one. All right. A couple things that this greatly affects. The first is that we see that cube is at 2, 0, 0. Okay? It's at 2, 0, 0. That's where we put it. But if I click on the sphere, notice where it's at. It's at negative 4, 0, 0. Now you should be thinking, why isn't that at negative 2, 0, 0, where we put it? because now that the sphere is nested under the cube, it no longer listens to the world coordinate system. It instead listens to the local coordinate system of the cube. Alright, so it knows it is minus 4 units away from the cube. It does not care that it is only minus 2 units from the original origin. In fact, if I were to put this at 0, 0, 0, it would be centered on the cube now and not on the world's 0, 0, 0. So you have to keep in mind that once an object is nested, alright, it is relative to the object it is nested under for its transform. This is important. A lot of times when people start working with Unity and they're like, why isn't this cube going, or why isn't this sphere going where I want it to go? What is happening? Why? It's not at -4. Why is it saying -4? They're forgetting that it is nested and thus it behaves differently now. In fact, since this sphere is based off of this cube's local coordinate system, if I select the cube and I hit rotate, alright, we're going to see some strange behaviors there. And this is actually, wait a minute, let me fix this here. I want to click up here to global. There we go. Oh, there we go. Let's see. It's not rotating the way I want. Let me unnest this. To unnest something, by the way, just click and drag it away. And now it's not nested anymore. There we go. And now, let's see. I'm trying to remember. There we go. Okay. So now that I've set this to pivot and global, this is what I wanted to say. See. So now when I click this, notice how the sphere moves relative to the cube. Okay? This is because the sphere knows that it is -4 away from the cube on its x-axis. If the x-axis keeps changing, the sphere keeps changing. Notice how the sphere is still -4 with no other translations and no other rotations. However, if I move it out here, it still thinks it's -4 with no translations and no rotations. It is only relative to the cube. It has no idea where else that it is at. Alright? I can do all sorts of rotations with it. And again, -4, no other translations, no other rotations. Okay? So by controlling the parented object, I can control all the children objects. And that gets very, very, very useful if we're trying to do things like smooth curving around a cylinder or whatnot. We can actually create a cylinder, put all the objects on the cylinder, and just rotate the cylinder, and they all move. Okay, that's a very powerful tool. It's a very powerful feature for us to have and for us to be able to use to manipulate our objects. Sorry about that. We saw the toolbar there again. Now let me reset the rotations on this. There we go. Back to normal. Okay. I can click and hold the sphere and unparent it, and now I can click and hold the cube and parent it to the sphere. Alright, I can certainly do that. And now if I move the sphere, the cube moves however I want to manage that. I can also click this pivot. Alright, so I see pivot right here, which is this button right up here in the scene, or right above the scene view, which allows me to pivot an object. However, since they're a group, if I change this to center, right here, now I can see here in the that I can move both objects relative to each other. Okay, and they both get basically half of the rotation. Oh, actually, this one still is the way it was. This one gets the full rotation. But anyway, okay. So it's just a matter of preference and workflow as to which of these you use. I'm used to leaving pivot on, which is kind of why it caught me for a second when I saw it in the center there, and I had to remember exactly how we do that because that's not something I work with all that often. Okay, so let's kind of undo what I did here real quick. So let me unnest these, put my cube back at 2, 0, 0, kind of no rotation here, basically refresh, and this one here I'm going to put it -2, oop, not -5, -2, 0, 0, just like that. Okay, so we can kind of move these things back. The amount of nesting that we do is not limited, okay? So for instance, I could do game object create empty, right? And I could put this empty game object at 0, 0, 0. I could nest the sphere into the game object and the cube into the game object, so they're both in the same level of the game object. And now I can, you know, achieve where I rotate them like this again. Let's say I were to translate it, they would all translate. All right, and so I can do that, or I can nest the sphere under the cube under the game object. Now the sphere moves relative to the cube, which in turn moves relative to the game object. All right, so we can achieve some very advanced ways of transforming our game objects. This is important to remember because I guarantee you as you're working with this, you're going to become at one point confused why something is moving so weird when it should be moving much more straightforward and normal. It's going to seem kind of odd that it in fact is not. All right. Okay, so let's go ahead and kind of undo everything I just did there. All right, fantastic. So at this point, I kind of just want to recap and kind of summarize and get us ready to wrap this up because it's getting to be close to about an hour. I'm trying to keep it to about that. So the things we've talked about today. We talked about the 2D versus 3D coordinate systems, which are based on the Cartesian coordinate systems, and they're how we make both 2D and 3D games respectively. Since Unity is a 3D engine, it is basically made for 3D games. However, we can make 2D games by simply just disregarding the z-axis. All right, if we just don't use the z-axis and we set our camera to orthogonal, orthographic, then all of a sudden we can make 2D games just as well. All right, not to mention that Unity will be releasing 2D tools here in, I believe, version 4.3. Okay, we talked about the local versus world coordinate system and how that affects how things move. And how things see other things and how things know where they're at. So the 2D coordinate, or the local versus world coordinate system is very important to remember when we're talking about different transformations and how they affect the transform. Okay. We talked about the game objects and how game objects are basically empty containers where we can stack different components. And we talked about the different components. We talked about the different things they can do. We talked about how if we click one and add component and effect, we can add a particle system and another one, add an effect. We can do a trail render, which actually won't have any visual, so that was boring. Let me do another particle system. We can add particle systems everywhere. And if we look in our game view, everything's just got particles. Okay, so we can add these components, real simple, and add a lot of functionality there. We talked about the different transformations. We talked about the transform, and that the transform is the sum is basically an object's position, its rotation, and scale, all summarized together. A transformation is how we affect the transform, and there are three transformations. There's translation, which changes your position, rotation, which changes your rotation, and scale, which changes your scale. All right. Finally, we talked about parenting and nesting objects, which allows us to put one object into a group with another object, with one object being the parent, the other one being the child. Again, called nesting. I can't remember if I said that or not. Basically, when we nest or parent our game objects, they affect each other's transformations because the world coordinate system of the child object is actually the local coordinate system of the parent object. And it's important to keep that in mind while working on this stuff in case anything seems to be moving or behaving strangely. Okay, so that's going to wrap it up. Now, I want to kind of remind you all, or tell you maybe if you didn't know, that if you go to unity3d.com/learn, we have a lot of material available free for anyone who wants to view it. And actually, let me pull this up for you here, just so you have a chance to see it. You're going to see all my stuff I visit, so there you go. You get to see everywhere I go. I apologize. I probably should have thought of that ahead of time before opening that up. But if you go to unity3d.com/learn, you see Learn with Unity, and we can see the different tutorials, documentations, our great community, and live training. And the tutorials, fantastic stuff here. We have topics on all sorts of different things. Basically, feel free to go through here, learn about the different things that we have made available to you. Another thing I want to talk about is our Twitter. You can reach us on Twitter if you have any questions or any feedback that you'd like to give us. You can reach us at Unity3D. I am Mike Geig. You can reach me at Mike Geig. Will Goldstone at Will Goldstone. And Adam Buckner. Hopefully I said that right. Or it might be Buckner. Let's see here. Nope, Buckner, I was right. At the Ant Ranch. Okay, so feel free to contact us with any questions or feedback that you might have. We'd be more than happy to help you out and answer any questions that you have. So thank you.